Hello, everybody. My name is Nicole Crow, and today I'm going to be discussing nuclear waste management. Before we talk about nuclear waste, I would like to mention some of the justifications for nuclear power. Nuclear power is not a renewable form of energy, as its fuel source of uranium is only available in finite amounts. However, it is considered to be a clean form of energy because it does not release greenhouse gases like CO2. Additionally, nuclear power has the highest energy return on investment, meaning that while nuclear power plants have significant costs initially, it is very cost effective in the long run due to low maintenance costs. Nuclear power also uses less land than hydro dams or solar farms, which is important in a world with a rapidly growing population. So let's talk about nuclear waste now. Uranium is the primary fuel source for nuclear power. It is mined, refined, enriched, and then compressed into fuel rods. Once in use at the reactor, the uranium atoms stored inside will be split, producing massive amounts of energy and fission products, such as radioactive isotopes. Nuclear waste is classified into three categories based on the amount of radioactivity: low level, intermediate level, and high level waste. Low-level waste makes up about 90% of nuclear waste and yet only 1% of its radioactivity. On the other hand is high-level waste, which makes up only about 3% of total waste but is responsible for 95% of radioactivity. There are three forms of management for nuclear waste, all of which are typically followed in steps. There is reprocessing and recycling, vitrification, and storage in repositories. Reprocessing and recycling is often a first step in waste management, as up to 95% of spent nuclear fuel still has energy potential. There are a variety of similar procedures to do this, but the most common one is known as Purex reprocessing, in which fuel is dissolved in nitric acid and then a solvent tributyl phosphate separates uranium and plutonium to be reused as fuel. Reprocessing is a sustainable practice that is not only beneficial for the environment, as it allows us to mine less uranium, but it also reduces future risk, such as that recycled fuel will produce less heat and less toxic waste. Vitrification is the second step in management. Vitrification is the process of turning liquids, such as remaining nuclear waste, into solid, durable glass. Remaining nuclear waste is melted and combined with additives that help form glass as the mixture cools. This is beneficial because vitrified waste creates a durable product that is easier to transport and store, traps dangerous contaminants, and reduces the volume of waste that needs to be stored. The final stage of nuclear waste is storage in a repository. Except for one repository in the world, all repositories currently only offer temporary storage. A permanent repository must be a deep geological repository, meaning that waste is placed in metal canisters which are then stored in a facility about 200 to 1,000 meters underground. This depth is necessary so that the highly toxic waste does not contaminate the air, soil, or groundwater. Currently, the only operational deep geological repository that can permanently store nuclear waste is in Onkalo, located in Finland, which is projected to begin operations this year. In 1987, the US government proposed a deep geological repository at Yucca Mountain in Nevada. However, due to backlash from residents and political disagreement, this repository was never built. Overall, nuclear power is an important alternative to fossil fuels and currently already generates 10% of the world's energy. Nuclear power is a viable energy source that is worth investing in. However, nuclear waste is an important factor that must be considered if a transition towards nuclear energy is to occur. Thank you.